What China discovered on the far side of the moon is a story that's been billions of years in the making, hidden right in plain sight. For as long as humans have been walking this earth, we've looked up at the night sky and seen the exact same face staring back at us. It's a comforting, familiar sight. The man in the moon, the craters we've named, and the spots we've mapped out since the dawn of time. But there's a catch. Because of the way the moon rotates, there's an entire half of it that has remained a total secret, tucked away in a permanent state of radio silence. It's been this massive, unexplored void that we could only guess about. We used to call it the dark side, but that's not really accurate. It gets plenty of sunlight. It just never shares it with us. For centuries, it was the ultimate keep-out zone of our solar system. But that silence was finally broken. What the Chinese space program found when they finally touched down back there isn't just a few cool rocks or some dusty craters. They stumbled upon a geological crime scene that's forcing us to rip up our old textbooks. We're talking about discoveries that challenge every single thing we thought we knew about how our closest neighbor was born and how it evolved. This isn't just a sequel to the Apollo missions. It's an entirely different genre of science. We're finally seeing the side of the story the moon tried to keep hidden. And honestly, it's nothing like what we expected. It's rugged, it's mysterious, and it's finally talking. To understand how we got here, we have to look at the sheer audacity of China's Chang'e missions. Landing on the near side of the moon is hard enough, but landing on the far side, that's a whole different ball game. You can't even talk to Earth from there because the entire mass of the moon blocks your signal. In 2019, the Chang'e 4 mission pulled off the impossible by making the first ever soft landing in this lunar wilderness, proving we could finally reach the unreachable. Then, just recently in 2024, the Chang'e 6 mission upped the ante by actually grabbing physical samples and bringing them back home. They didn't just pick any random spot either. They headed straight for the South Pole-Aitken basin. If you're looking for the moon's deepest secrets, this is the place to find them. It's one of the biggest, oldest, and deepest impact craters in the entire solar system. A massive scar from a collision so violent it nearly cracked the moon open. The thing is, the far side isn't just the other side, it's a completely different world. While the side we see is covered in those smooth, dark patches of ancient lava called Maria, the far side is rugged, mountainous, and absolutely battered by craters. Scientists have spent decades wondering why the two sides look so radically different, and the data coming back from these missions is finally giving us the why. By digging into this specific region, China has essentially opened a cosmic time capsule. We're not just looking at lunar dirt. We're looking at the raw materials that formed the Earth-Moon system billions of years ago. We're realizing that the moon has a much more complex, much more active history than we ever gave it credit for. This is the story of how a few scoops of gray dust are changing our entire perspective on the cosmos. When the Chang'e 6 return capsule finally streaked through Earth's atmosphere and touched down in the grasslands of Inner Mongolia, it wasn't just carrying a few pounds of lunar dirt. It was carrying the physical evidence of a world we had only ever seen in grainy photographs and distant radar scans. For decades, our entire understanding of lunar geology was built on the foundation of the Apollo missions and the Soviet Luna probes. Those missions were incredible, but they had a blind spot. They all landed on the side of the moon that faces us. It's like trying to understand the entire geography of Earth by only looking at the Pacific Ocean. You're going to get a very skewed perspective. The samples brought back by China have finally allowed us to look at the other half of the ledger, and the results are honestly staggering. The most immediate and shocking discovery came from the chemical fingerprinting of the basalt, the dark volcanic rock that makes up much of the lunar surface. For a long time, the prevailing wisdom was that the moon was a geologically dead world, and had been for billions of years. We thought the volcanic fires had burned out early in its history, leaving behind a cold, dormant husk. But the Chang'e 6 samples tell a different story. Scientists found basalt fragments that are roughly 2.8 billion years old. Now, in the grand timeline of the universe, that might sound like ancient history, but in lunar terms, it's surprisingly recent. It means that the far side of the moon was still geologically active, with molten lava flowing across its surface, much later than anyone predicted. This discovery of late-stage volcanism is a massive curveball for planetary scientists. It forces us to ask a very difficult question. How did the moon stay warm enough to produce lava for that long? Usually, a small body like the moon loses its internal heat pretty quickly. It's like a small cup of coffee compared to a large pot. The smaller one cools down way faster. To keep the volcanic engine running for nearly 3 billion years, you need a heat source. On the near side, we always assumed that heat came from a specific concentration of radioactive elements, things like potassium, rare earth elements, and phosphorus, which scientists call the creep terrain. These elements decay and generate heat, which acts like a slow-burning furnace under the crust. But here's the kicker. The far side samples show almost no trace of these elements. There is no creep. There is no obvious radioactive furnace. And yet, the far side was still pumping out lava. It's a geological mystery that suggests there are deep internal processes within the lunar mantle that we simply haven't accounted for. We are looking at a world that refused to go cold, and we're still trying to figure out what was fueling the fire. The texture and composition of this soil, the lunar regolith, also reveal a much more violent and complex history than the soil from the Apollo sites. Because the far side is constantly exposed to the open debris of deep space, without the Earth acting as a shield, the soil has been pulverized and churned by billions of years of micrometeorite impacts. It's thicker, it's more rugged, and it's filled with exotic minerals that are rare on the near side. When you look at these samples under a microscope, you're seeing a chaotic mix of minerals like plagioclase and pyroxene, but in ratios that don't match the familiar moon. This isn't just a different neighborhood. It's a different continent with its own unique chemistry. This brings us to the overarching mystery that has haunted lunar scientists for over 60 years. The Great Lunar Asymmetry. If you look at a map of the moon, the difference between the two halves is jarring. The near side is dominated by the Maria, those vast, dark plains of ancient lava that look like seas from a distance. But the far side is a fortress of mountains and craters, with almost no lava plains to be seen. It's lopsided, like a piece of fruit that ripened only on one side. For a long time, we thought the far side was just too thick for lava to break through. The idea was that the crust on the far side was like a heavy lid on a pot, keeping everything trapped underneath. But the data from the Chang'e missions, specifically the exploration of the South Pole-Aitken basin, is giving us a much more nuanced view. This basin is a monstrous feature, stretching over 1,500 miles wide and plunging miles deep into the lunar interior. It's so deep that the original impact billions of years ago likely peeled back the moon's crust and exposed the mantle underneath. By landing there and taking samples, China has essentially performed a deep tissue biopsy on the moon. What they've found suggests that the difference between the two sides isn't just about the thickness of the crust. It's about how the moon's internal organs were distributed from the very beginning. We are starting to see that the moon didn't cool down uniformly. It was a messy, lopsided process. This asymmetry is a direct window into the most violent moment in our planet's history. Most scientists agree that the moon was formed when a Mars-sized planet, which we've named Theia, slammed into the early Earth. It was a collision of such unimaginable scale that both worlds were essentially liquefied, and a massive cloud of debris was blasted into orbit, eventually clumping together to form the moon. But if the moon formed from this giant splash of molten rock, why isn't it the same all the way around? The Chinese data is helping us piece together the magma ocean theory. The idea is that in its infancy, the entire moon was covered in a sea of liquid rock. As it started to cool, the Earth was already a massive, glowing ball of heat nearby. The side of the moon facing the Earth stayed hot and molten for much longer because it was being baked by the Earth's radiation, while the far side was facing the cold vacuum of space, allowing it to crust over and harden much faster. This lopsided cooling meant that the far side developed a much thicker, more rugged shell, while the near side remained thin and fragile. Later, when radioactive elements deep inside the moon began to generate heat, the lava found it much easier to burst through the thin crust on the near side, creating the seas we see today. On the far side, the lava was mostly trapped behind that thick, cold wall of rock, only managing to leak out in rare, mysterious events, like the ones that created the 8-billion-year-old rocks China just found. But there's an even deeper connection here. When we analyze the mantle material exposed in the South Pole-Aitken basin, we aren't just looking at the moon. We are looking at the remnants of that original collision. We are looking at the DNA of the Earth and Theia, mixed together and frozen in time. Because the moon has no wind, no rain, and no plate tectonics to erase its history, it has preserved the evidence of our own planet's birth in a way that the Earth itself never could. The Earth is a master at hiding its past. It recycles its crust, it erodes its mountains, and it covers its scars with oceans and forests. The moon, however, remembers everything. By exploring the far side, we are effectively looking at a mirror of our own ancient past, seeing the debris of the very collision that gave us our tides, our stable rotation, and perhaps even the conditions necessary for life to begin. Every rock China brings back, every mineral they identify in that silent, cratered wilderness, is a new sentence in the biography of our own world. We're realizing that the moon isn't just a satellite, it's a witness. It's a time capsule that has been orbiting us for 4.5 billion years, waiting for us to finally be brave enough and curious enough to look at its hidden face. The discoveries of the Chang'e missions have turned the moon from a familiar neighbor into a profound mystery, proving that even the things we think we know best still have the power to surprise us. We're no longer just looking at the man in the moon. We're looking at the raw, unedited history of the solar system, written in the dust of a world that was once a part of our own. As we continue to sift through the data and the physical samples, one thing is becoming crystal clear. The far side of the moon isn't just a dark, empty void. It's the key to understanding where we came from, and it's finally starting to give up its secrets. The mystery of why the moon has two such radically different faces is one of the oldest puzzles in planetary science, and the data flowing back from the far side is finally allowing us to look under the hood of this cosmic anomaly. When you look at the moon from your backyard, you're seeing a world defined by its seas, those vast, dark, basaltic plains that were formed by ancient volcanic eruptions. For decades, we simply assumed the whole moon was like that. But when the first Soviet probes looped around the back in the late 50s, they sent back images that shocked the world. There were almost no seas. Instead, it was a battered, high-altitude wilderness of endless craters. It looked like a completely different celestial body. This lunar asymmetry has been the subject of endless debate, but the Chinese missions, particularly the sophisticated radar and mineralogical mapping from the Chang'e orbiters and landers, have provided the smoking gun. It all comes down to the crust. The crust on the near side is relatively thin, which acted like a fragile shell that allowed the hot, pressurized magma from the interior to burst through easily during the moon's early, violent youth. But on the far side, the crust is significantly thicker. In some places, it's twice as deep as the crust we're used to. It's a massive, rocky fortress that kept the volcanic fires bottled up inside. But why is the crust so lopsided in the first place? This is where the story gets truly incredible. linking the moon's current state back to its hellish birth. The prevailing theory, bolstered by the new data, suggests that shortly after the moon formed from the debris of a massive collision with Earth, it was tidally locked to our planet almost immediately. This means that even back then, one side always faced the Earth. At that time, the Earth wasn't the blue and green marble we know today. It was a scorched, glowing ball of molten rock, radiating an immense amount of heat. Because the moon was much closer to Earth back then, the near side was constantly being baked by this planetary furnace, kept in a molten or semi-liquid state for much longer. Meanwhile, the far side was facing the freezing void of deep space. It cooled down rapidly, allowing minerals to crystallize and build up a thick, sturdy crust, while the near side was still a bubbling ocean of magma. By the time the near side finally cooled enough to form a solid surface, the far side was already a mountain of rock. This lopsided cooling process didn't just change the surface, it redistributed the moon's internal chemistry, pushing those heat-producing radioactive elements toward the near side, which only served to keep that half of the moon geologically active for even longer. The South Pole-Aitken basin, where China focused its exploration, is the ultimate laboratory for studying this ancient history. Because the impact that created this basin was so powerful, it acted like a giant shovel, digging through the thick crust and exposing the lunar mantle. The samples collected by Chang'e 6 are essentially pieces of the moon's deep interior that have been sitting on the surface for billions of years, waiting for someone to pick them up. When scientists analyze these rocks, they aren't just seeing lunar history. They are seeing the pristine materials of the early solar system. Unlike Earth, where plate tectonics and weather have recycled and erased the rocks from 4 billion years ago, the far side of the moon has kept them perfectly preserved in a vacuum. This is why the far side is often called a capsula do tempo, or a time capsule. It holds the record of the Late Heavy Bombardment, a period about 3.9 billion years ago, when the inner solar system was slammed by a wave of giant asteroids. By dating the craters and the rocks on the far side, we can create a precise timeline of when these impacts happened, which tells us exactly when the Earth was being pummeled too. We are learning about our own planet's violent childhood by studying the scars on its neighbor. But the discoveries aren't just about looking backward. They are about the future of humanity in space. One of the most subtle but profound discoveries on the far side isn't a rock or a mineral, but a unique environmental condition: silence. Because the entire mass of the moon sits between the far side and the Earth, the far side is the most radio-quiet place in our local neighborhood. On Earth, our atmosphere is buzzing with the noise of billions of cell phones, radio stations, satellites, and power grids. This electronic fog makes it incredibly difficult for radio telescopes to hear the faint, ancient signals from the early universe, the whispers from the first stars, and the dark ages before galaxies formed. China's missions have already begun testing low-frequency radio spectrometers in this zone, and the results are a dream come true for astronomers. The far side offers a window into the deep cosmos that simply doesn't exist anywhere else. It is the only place where we can truly listen to the universe without the interference of human civilization. This makes the far side the prime real estate for the next generation of telescopes, which could potentially see back to the very beginning of time itself. Furthermore, the mapping of the lunar poles has confirmed the presence of something even more practical: resources. In the permanently shadowed regions of the craters near the South Pole, where the sun hasn't shone for billions of years, there are vast deposits of water ice. This isn't just a curiosity, it's the gold of the new space age. Water can be broken down into hydrogen and oxygen, the two main components of rocket fuel. If we can harvest this ice, the moon becomes a gas station in the sky, a jumping-off point for missions to Mars and beyond. It's much easier and cheaper to launch a heavy rocket from the moon's low gravity than it is to haul everything up from Earth. The far side, with its rugged terrain and hidden ice, is no longer just a mystery to be solved, it's a strategic frontier. The Chinese missions have proven that we can land there, we can operate there, and we can even bring pieces of it back home. They've laid the groundwork for what could eventually be permanent lunar bases, where humans live and work on a world that was, until very recently, completely invisible to us. As we wrap our heads around these discoveries, the most significant takeaway is a shift in perspective. For the longest time, we viewed the moon as a dead, static object, a cold rock that just happened to be stuck in our orbit. But the far side has shown us a world that is geologically complex, chemically diverse, and deeply connected to our own story. We've learned that the moon is a witness to the birth of the Earth, a shield that has taken hits meant for us, and a record keeper of the solar system's most chaotic eras. The man in the moon that we see every night is only half the story. The other half is a rugged, mountainous, and silent wilderness that holds the keys to our past and the maps for our future. China's journey to the far side has effectively ended the era of speculation and begun the era of exploration. We are no longer just looking at the moon. We are finally starting to understand it. And in that understanding, we find ourselves looking at a mirror. The rocks and dust of the far side are a part of us, remnants of the same celestial fire that formed our mountains, our oceans, and eventually, the very people who are now reaching back out to the stars to reclaim their own history. The silence of the far side has finally been broken, and the story it's telling is more spectacular than anything we could have imagined.